All right, welcome. Here we are back. Mr. Boone, your professor, back again. Video learning here. We got 11.1. We're going to talk a little bit about permutations, combinations. In chapter 11, of course, we're going to be doing a lot of statistical type of work. Some of the stuff you've seen before, we'll kind of extend that on here. But first thing we're going to talk about, we'll learn about is the fundamental counting principle. And what that is learning how many different ways there are to do some things. Okay, so an example might be something like this. You're going to make a yogurt parfait. Now we have 2 flavors, plain and vanilla. We have 5 different types of fruits that we can have on there and 3 different types of nuts. So we want to know how many different ways, how many different parfaits can we choose. And the fundamental accounting principle just basically says we're going to multiply all the options together. All right, pretty easy on how to do that. So again, if we kind of look at this here, we're going to take the number of flavors, 2, number of fruits, 5, 3, multiply them together, there's 30 choices. And again, you've done some stuff like that before in younger levels where you've done tree diagrams and then counted up how many there are. We're just going to get into the math thing. And if it helps you to do those tree diagrams, feel free to do that as well. Okay, so we're just going to multiply those out. All right, another situation. We have a password. We have 4 digits followed by 2 letters. So we're going to count to see how many different options are there. Well, letters A and Z aren't going to be used. So that means we have 24 choices if we're allowed to repeat, which it didn't say that we can't for the letter choices, but we got 10 digits. Remember, when we do digits, 0 through 9, there's 10 choices. So we have 10 choices for the first, 10, 10, 10, and then when we get to the letters, remember, since we're not using A and Z, there's 24 choices. We can repeat. So it's just a matter of multiplying those all together, so we end up getting 5,760,000. Okay, so that's our fundamental counting principle. Multiply the options. You have to think sometimes about how many there are in each level when we do that. All right, now we talk about those make your own adventure books. Those books are so great. When I was younger, you'd go through and say, hey, if you want to do this path, to go to this page, this path. We've all seen those before. So this one book that you buy has lots of different stories that you could get. We have 6 starting points, 4 plot choices, and 5 possible endings. So again, if we want to know how many different adventures are in this one book, well, we take 6, we're going to multiply that by 4, and then we're going to multiply that by 5. All right, altogether then we take that, 20 times there, 120 different stories in one book. Boy, you got your money's worth there, didn't you? All right, good deal, good deal. All right, so let's mosey on a little bit more now. We're going to be talking about permutations. Now, permutations, the thing you have to remember with this is that the order matters, okay? So BA is different than AB. And so look at all the options that you'd have if you had 3 choices. Yeah, the order does matter when you have these. So again, we have to learn a way to kind of compute those. Sorry about that. And there's some ways to do that, of course, and we're going to introduce this idea of something called a factorial. Factorial, it's a number followed by an exclamation point. All right. Now, what is that? Well, it's a helpful way of counting in statistics. And if you do 6 factorial, now remember, we read that 6 factorial. We don't just scream 6. But what you do then is you multiply. You start at 6, just go 6 times 4 times 6 times 5 times 4 times 3 times 2 times 1. It's like if you had 6 things that you're arranging on a shelf. Well, you have 6 choices for the first spot. Then you have 5, 4, 3, 2, 1. That tells you all your number of choices. So that's the factorial. Now, that's how you can compute the number of permutations that you have. But there's also a better way, and we're going to show you that on the calculator. Is what we're going to do is we're going to show you exactly how to do that in just a minute as we go. Let's get into a certain situation here, and then we'll show you calculator-wise how to do this, a couple things. All right, so people from a group, if you had 7 people in a group, but you wanted to select 3, and you want to kind of order them in a certain way, again, you're choosing a permutation. Now the question is, how do you get there? Well, obviously you have 7 choices for your first, 6 for your second, 5 for your third. Now there's another way of doing this. I'm going to go back to my desk quick, get the calculator up, and we're going to show you some calculator strokes here on the TI. And we'll be right back. Give me a second. Here we go. Let's get our calculator up and handy. Now, a couple of things that we're going to look for. First of all, if we go into the math button that's right here, follow along as you see the calculator strokes there, we're going to want to go over to the probability section. Hit math and go over to probability. All right, so we can see right there, we can see the factorial that we have there. And then we can see this is going to be the permutation, and in just a minute we're going to talk about what is a combination. So it's all off this same screen. All right, so let's just say, like we did before, let's say I want to do 6 factorial. Well, we type in the 6 first, then we go to math, then we're going to go over to probability. Go down, you can either scroll or just hit the number 4. There it is, 6 factorial. All right, look at that, gives you 720, okay? Now, if we want to do the thing where we had 7 people to pick from and pick 3, here's what you do. Always put the 7 first, the number that you're taking it out of, then hit math. Then we're going to go over to probability. All right, then we're going to go down to permutation because the order matters. We're going to pick 3 of them. And there we go, that's it. It tells us that there's 210 possibilities. So again, that's how you can do that. Again, it's the number that you're picking from, 7, and you're picking 3. It's a permutation, that's if the order matters. Okay, a little spoiler alert, combinations are going to be if the order doesn't matter, but we'll get to that in just a little second here. All right, so let's go back to our little screen here. There we go. All right, now again, those are some different ways of doing it. I like to just use the calculator there for that, so we're all good to go. Again, this is really what a permutation does, is it takes your number that you have and it divides it by how many you have minus how many you're choosing. So this is what it does. But again, just use the calculator. That'll do the permutation for you. Works like a charm every time. All right, so here we go. We have how many ways can a student government select president, vice president, secretary, and a treasurer from a group of 6? All right, so once again, the order matters, because it matters whether you're a president or a vice president or a secretary. So we have 6 that we're going to pick from, and we're picking 4. So this is what we say a permutation of 6, pick 4. So we go back to our calculator here. All right, we're going to figure that out. We're going to go 6. Here we go, and let's go over to probability. Go down to 2, that's the permutation. 6, pick 4. There we go, we hit that. All right, there's 360 different ways of picking 4 out of 6 people for those positions, because the order does matter. That's what makes it so many. Okay? So there we go on that one. So once we know how to set those up, pretty easy. Big thing you have to understand is whether the order matters or not. All right, how many ways can a stylus arrange 5 of 8 vases from left to right? So once again, the order matters, because whether the vase is in the first spot, second spot, not, we have to do that. So we're going to do a permutation of 8, pick 5. So once again, let's go to our calculator here. We have 8, hit the math button, go over to probability, and we're doing the permutation, and we're going to pick 5. And there we go, there's our answer. 6,720 ways of arranging those vases. Crazy, crazy. All right, try a couple others here. All right, now, let's talk about a combination now. Combination, notice the difference. Combination, the order doesn't matter. I'm just picking 3 people. So ABC is the same thing as BAC, CAB, whatever it is. So with combinations, there's going to be a lot less options because the order does not matter of how you do that. So once again, we'll kind of show you how to go through some of those. Again, you don't have to necessarily know that way, but again, with a combination, this is what the calculator is doing. You don't need to know that. We just need to know how to type it in and set it up. Okay, so again, we're going to use the word choose here for combinations. All right, so the big thing here is that you have to decide, does the order matter? Are we assigning people to certain roles? Does the order position matter? Okay, if it doesn't, we're using a combination. If it does, we use a permutation. So again, this is on that same screen instead of the permutation. This is the combination one. Pretty easy. P and C should be pretty obvious which way we do it. All right, so here we go. So now, there are 12 different colored cubes in a bag. How many ways can you draw a set of 4? Now, this is, again, one of those cases where the order that you grab them doesn't matter. Okay, you either grab them or you don't. So this is a combination of 12, choose 4. So let's go back up here. Let's just type it in. We go 12. Get that 12. Hit math. And then what we're going to do is go over to probability. And this time we're going to go down to number 3 because we're going to choose, it's a combination. 12, choose 4. There we go, it's 495 is what we get. Now back in our old school days, we used to have to go by the definition of a combination, figure it all out, do some chunga-chungas here, and notice how you get the same answer. Calculator's doing a lot of work for you if you know how to set it up. Okay. All right, let's do one more here. Swim team has 8 swimmers. 2 swimmers are going to be selected to swim in the first heat. How many ways can the swimmers be selected? Now again, it doesn't matter if the order that you're selected, either you're in the heat or you're not. Okay, so this is going to be a combination. We have 8, we're going to choose 2. So let's go back up to our calculator here. Let's do 8. And then we go over probability. And we're going to choose 2. There it is. How many different ways? Well, according to this, there's 28 different ways that you can choose 2 people from a group of 8. Okay? All right, guys. That's what we have for today. For 11-1, again, we want to get that done this first week. We'll be in and out here with the videos. Hopefully this helps. You can always go back and watch. If you have any questions, feel free to email me. But this is 11-1. You should be able to go on, do the worksheet. The key is provided. Go through that. If you're not getting something, not sure why, that's a great time to ask for questions. So let me know. Good luck to you, and we'll be back for 11-2 in just a little bit.